So in this next video, we will apply our concept of energy flow or power in solving problems related to energy flow or problems or power. But before we do so, let's just review and tabulate the different equations that we're going to be using based on what we have in the previous page. Power is defined as the ratio or the amount of work divided by time. So that will be our definition, or energy, or what type of energy divided by time. So what is the equation? Well, I already wrote the equation right here, but more exactly, we should be writing the equation over here, which is power is work over time. Or if we're using energy, then power should be energy over time. What are two information that you must know when you're solving the problem? What are two information that you must know in order to solve the problem? Of course, the first one is either work or energy. It depends on what is provided to you. And the second one, you must know your time. So these are the two things that you must have in order to solve for power. The next one is work or energy. Again, if we're solving for work, it's either solving for W. Are we solving for energy? Now, if it's very specific, what type of energy? So we can say it's either potential energy or you are solving for kinetic energy. So the equation can be written as work is simply equivalent to whatever the power is or the flow of energy multiplied by time, or P times T. Or if we're solving for energy, energy is simply equivalent to power times time. So it's the same one, just like what I said, it's either we're working for energy or power. So in our case, in order for us to solve for it, what's on the right side of the equation, we need to know our power, and at the same time, we need to know our time. Now, last but not least, if we're solving for time, okay, so T is something we want to solve for. So our equation would look something like this. So time is simply your work divided by the power or the flow of energy. And if you were provided with energy, and that is simply change your W with E, which is your energy, over P, divided by the flow of energy or divided by the flow of power, or divided by the power or flow of energy. In terms of what needs to be provided or what you need to know, so anything on the right side of the equations. So you need to know your W or E, or what kind of energy is provided, and then also you need to know what is the power provided. So now let's apply these equations in the next couple of problems. A sleigh is pulled by a horse with a 200 Newton force. So allow me to highlight 200 Newton force at a distance of 1 kilometer, so kilometers, in 45 minutes. 45 minutes. So the question is, what is the power? What is the power? So the power equation, we're solving for power. So basically, we're going to use the first row. Okay, so the first row, and we will use the amount of work done in terms of solving for power. So power, we don't know, but we all know that power is simply equivalent to work over time. Now let's analyze what is work. Work is something that we can solve for because this one is in terms of force. So we have a force of 200 newtons, and then we also have a distance of 1 kilometers, or 1 kilometers is basically 1,000 meters. So this is our distance d. And then 45 minutes is your time. So first thing that we have to do is solve for work. So what is work? Work is simply the force dot multiplication distance. And that is force of 200 newtons. Again, this is kilometers, so our unit should always be in meters. So let's change this into meters. And that is 1,000 meters. So 1 kilometer is 1,000 meters. So multiplying these two numbers together, so that will give us 200 and then 3 additional zeros. So that is 2,000 joules. Okay, 2,000 joules. Now in terms of time, let's take a look at time. Time is provided in terms of 45 minutes. But we all know that we're not going to be using minutes, but instead we're going to use seconds. So let's convert this into seconds by multiplying it by 60, because there's 60 seconds per minute. So for every minute, there are 60 seconds. So by multiplying 60 and 45, or 45 and 60, then we have value of 2,700 seconds. Now going back to our equation to solve for power, let's plug in the values, which will give us 200,000 joules divided by 2,700 seconds. So this will give us 200,000 divided by 2,700. Therefore, power is equivalent to 74.07 watts. And that is in terms of W. So that's how you work on this example. Now this time it's still the same process. A force of 1,800 newtons exerted by a horse to move a wagon at a speed of 0.4 meters per second. What is the power of this horse? Okay, what is the power of this horse? So this is almost the same as this. Okay, this is almost the same as this one. It's almost the same as this. The only difference is that there's a little bit of a modification in how the problem is being presented. So if it is 1,800 newtons, that is equivalent to your force. The other information that you are provided with is your speed, which is also known as the velocity, which is 0.4 meter per second. The question is, what is the power? So we are solving for power. So let's solve for the power. First row, the equation for power is simply power is work over time. Okay, work over time. So power is work over time. Let's analyze. In order for us to solve for work, we must multiply the force by the distance. Okay, let's multiply the force by the distance. We are provided with a force of 1,800 newtons. However, we're not provided with the distance, but we have 0.4 meter per second. So if we will analyze this, velocity or speed is simply equivalent to distance over time. Distance over time. So if we place this, okay, if we place this instead of distance by itself, you will notice that work is also equivalent to force. Okay? That is velocity. So let's put velocity. Okay? So if we put velocity, that will be distance over time. This is not work anymore, but instead it's work over time. So what is work divided by time? It's also power. So therefore, multiplying the speed of 0.4 meter per second times the applied force of 1,800 is also equivalent to the power of the horse. So just revisiting and revising the equation, plugging in that value. So the power is basically the force, which is 1,800 newtons, multiplied by the velocity, and that is 0.4 meter per second. So now our answer is, so let's multiply 1,800 times 0.4, and that will give us 720 watts, or Newton meter, which is joules, divided by seconds, so that will give us watts. Hope you're following along with the problems. Now, the last problem for us to solve is as follows. A force of 100 newtons is used to move the object at a distance of 15 meters and a power of 25 watts. The question is, find the work done. So there's two things that we have to solve for, and the time it takes to do the work. So basically, we are solving for W, which is your work, and then time. 100 newtons is equivalent to your force. 50 meters is your distance. Power is 25 watts. So let's start with work. What is the definition of work? Work can be expressed in terms of the equation force times distance. Okay, force times distance. Or, what if in an equation that we know the power, it can also be solved using this equation, power times time. However, in those two equations that we have, we will only use the first one because this equation, we have all the given information. And what is the force? That is 100 newtons. Multiply it by a distance of 15 meters. Therefore, we have 1,500 newtons in terms of work. 1,500 newtons in terms of work. Now, let's solve for time. Okay, so let's solve for time. According to the last row, time can be solved by dividing your work, the amount of work done, by the power or the flow of energy. Now we know our work, which is solved from the previous question, which is 1,500 newtons. And that is not in newtons. It's a good thing that we were able to go back and check. This is in terms of joules. Okay, pardon me about that mistake. So it's supposed to be 1,500 joules, and then the power is given at 25 watts. So let's plug in the values of 1,500 joules divided by 25 watts. Therefore, the amount of time to do this amount of work is 1,500 divided by 25. So that will give us 60 seconds, okay, overall in terms of time. So it will take us 60 seconds to complete this work.